Hello, welcome to Data Analysis with Python. In this video, let's do a capstone project on pricing recommendation tool. Maybe you sell stuff and those things have certain things that determine the price from month to month, from week to week, or something like that. That's what this project is about, pricing recommendation tool. So this analysis explores the pricing recommendation data set uh, by examining seasonal trends, competitor comparisons, and predictive modeling to derive actionable pricing insights. Now, this is already taking us into some kind of data science, which of course I'm going to do along the line. Probably after data analysis, I should be doing SQL or what SQL, or afterwards, I should be going to data science. Let's see how all of these things work. All right. So that's what we are doing. And for the data, right? For the data sets you're using, I'm using a made up. Almost all my data sets are actually made up, or they're either made up or they are already available on the in Python. If you follow what I've been doing all along, so we have pricing recommendation tool, a data set called that. So, and just like I've always recommended, I like to always see my data sets in its original form first. So this is a CSV data set, comma separated variables data set for pricing recommendation. So look at this columns. It has one, two, three, four, five, six columns, right? And then it has, I think, 100 data points. Yeah, 100 data points. That's what we have. So that's some good data set to work with. So now we have product ID. Of course, that's categorical for the most part. We have the months based on, so 7 is July, for instance, 4 is April, 11 is November. We have the competitor average price. So the average price of your competitors is 31.09 for the first product. For the second product is 59.64 and all that. Then this is you have the seasonality index too. So you have the seasonality index is 1.23 in July. It's 0.96 for product 2 in April. Then suggested minimum price, is for you is 36.33 and suggested maximum price. So based on this whole thing, you want to now you want to price your products based on these kinds of information. So you are taking season into consideration, you're taking your competitors into consideration to determine what price. You are taking the month, of course, that's the season, right? You are taking all of that into consideration to determine the price of your own goods. Okay, so the first thing we want to do is that data set you've seen, I want to load it and explore it as we've always done. So of course, import pandas as PD. That's what we need to read CSV, right? Read underscore CSV is a function inside of the pandas library that can help us read the CSV file. And then you can review the data set by just calling df. And then, of course, you can do head 50, head 5, and whatever you like. So here we have 100 rows and 6 columns. So you have all of those. You have all that product ID, month, competitor average price, seasonality index, suggested minimum price, suggested maximum price, and so on and so forth. So let's also look at the data summary and descriptive statistics. Well, starting with basic summary, right? Let's describe the data sets. So of course, df.describe shows you the statistical analysis of the numerical variables. Maybe that's okay. I've got, well, like in this case, I'm doing info later. Info gives you the number of rows and columns and the data types basically, but describe gives you a statistical overview of your data of the numerical columns. So everything here is numerical apart from, I think, apart from the product ID, which is categorical, right? I think so. All the data, you have all the data, then nothing is missing. Then the okay, for the month, right? Well, the mean month is July. That month is categorical in a way, right? But we just use the number to represent it. So this may not mean so much, right? So it means that you have minimum is one. That's every so you have everything from January to December. So most months considered is sometime around July or something like that. Then for the competitor average price now, so the mean is 63.3 roughly, and then the minimum average price is 30, the maximum is 99. For the seasonality indices, you have all these values too. The suggested prices, you have them, and the suggested maximum price, minimum and maximum price suggested, you have that. So the insight here is that you need to check for any anomalies such as extreme values or missing data. in this case, we don't have missing data because everything is. If you look at all the counts, we have 100 data points, just like this has told us, 100 rows and 6 columns. So, and all the 100 are completed. So it means everything is in order. So if you have anything missing, if you had 99 somewhere, it means one data is missing in that particular column. So, like that. So variables like seasonality index range between seasonality index. So the minimum is 0.81, the maximum is 1.30. Okay. I mean, I think to be more accurate, right? We can say that variables like the seasonality index regions between the minimum is 0.81. So I can say about 0.81 to 1.30. Okay. That's what we really have in this situation. Then we can also see, well, usually this should come before the data describe, but it's okay. DF describe. So this is coming. DF info now just gives you an overview of the data set. So you have, it tells you you have 100 entries numbered from 0 to 99. That's it, 100 data points now. Then you have the column, you have 6 columns with these data types. So everything, another way to know if you have missing data is the same. Non-null means where everything is there without missing. So everything is fine. Then you have everything is you can do calculations with everything apart from product ID, which is an object. Month is technically an object too, right? But it is at least an integer. So in case you need that to do some calculation, you can. So you can do calculation with month column, customer average price, seasonality index, suggested minimum price, and suggested maximum price. You can do calculations with them because they are either integer or float. So you can do calculations with them. And the memory being used is 4.8 plus kilobytes. Okay. Now let's begin to talk about some visual exploration now. So let's visualize the distributions. So the first thing we are doing here, okay, let me do it one by one for better impact. Okay, so let me create, okay, let me create new cell. Good. Now, so for distribution of competitor prices, right? Let's see how the competitor prices go. So we are doing a histogram plot, and then we are doing a KDE. I've forgotten what that means. So but it's when you have histogram and then you have a line passing through like that. Okay. So this is what you have now. So this gives you the distribution of competitor average prices now. So it probably you're selling a range of products. So the kind of product you're selling, this can give you a bit of insight into that. So this is the distribution of competitor average prices. Okay. So you have that distribution going on that way. And then you can also have control V, right? So seasonality index, you also want to see that. So you see the spread of the seasonality as it is going like that, So you have, you can all these top bars also teach you a particular kind of lesson. So you also want to see the suggested price range versus competitor price. So you want to see if your pricing is going to scare people away. So you want to look at your competitors. You want to give people a good price so they can patronize you as much as possible. So what we are doing here is we want to add midpoint of suggested price. So you have suggested mid price is equal to suggested minimum price plus suggested maximum price divided by 2. So you want to see all that. Then you now want to do a scatter plot where you compare competitor average price with your suggested mid price. And then you want to color that with seasonality index, and then you can choose your palette. That's talking about color now, and then you do all the other things you need to do, and then this is what happens here. Okay, so you have the competitor average price on the x-axis and the suggested mid price on the y-axis. That, and from the look of things, right, they are positively correlated, right? So as your competitor average price rise, you can also price high too, like that. That's what this tells us about. And then they have been colored with the seasonality indices. I think that's what we have up there. So we have done cool warm. Like I always like rainbow. I always like to see what the rainbow thing looks like. So this is what we have in this situation. So you can change, you can use VRDs, you can use CVDs and all those things. What if we do greens? Let's see what that gives. Maybe that's going to give an error because the green should be capital G. Greens, yellows, yeah. This is how this goes. So it all depends on how you want it to be. So the insight is here is that most suggested prices are above competitor prices, indicating premium pricing based on seasonality. So if you feel you do a great, I mean, because probably your product is superior to your competitor's price, right? So you can have a liberty to, to price your goods so high, but making sure that it is not so high as to chase away the customers. So that's what we have. So your own pricing, so you have them positively correlated with your competitors. Then we can also do month-wise seasonality effect. So looking at the months, right? How did the months go? So you have monthly seasonality. So you group by month and then find it, and then do the average of the seasonality indices of the months, and then you use a plot to visualize what you have here. And this is what you have. So you see, you have peaks at May and November. So those are the tallest bars, right? So the insight is that peaks in May and November suggest strong seasonal demand. So it means that you should be ready based on the data you have now. So this is May already, right? We're in May, so it means you need to be sure you can meet your customers' demands a lot, and then you prepare ahead of November, which is another peak time. Of course, December is also up there and all that, but so you can see the seasonality index per month now. So we can also do correlation analysis, right? You want to see, for instance, correlation analysis of all the values like competitor average price, seasonality index, suggested minimum price, suggested maximum price, suggested mid price, and things like that. So we want to do a correlation of all that to two decimal places. So this is what we have. So, I mean, this is interesting actually because we see that so apart from the diagonal now, you can see that there are other ones in other places. So it means there are very strong correlations in this particular case. Let me do the rainbow thing I always like to do. Okay, not making too much difference, but it's fine. Okay, so you see there are many ones all over the place. So you see there's apart from the diagonals now, so all this one suggested maximum price is strongly correlated with suggested minimum price. Suggested mid price is strongly correlated with suggested mean price and all that. So the weakest correlations, on the positive side, you have seasonal index is positively correlated, but it is weak compared to with suggested minimum price. Okay, and then talk on the negative side of things. Seasonality index is not is weakly negatively correlated with competitor average price. So this can give you some insight into what you can do. So suggested prices are positively correlated with both seasonality and competitor pricing, though more with seasonality in this sample. Okay, so we see that. Then what if you want to do pricing model suggestion? Okay, here we're already going into some kind of data science, but it's okay. So if you can do scatter plots, right, you're already getting close to linear regression. But we'll do all these data science kind of thing in deeper details in another playlist, hopefully sometime soon. So here we're already doing bringing SQL and linear model for linear regression. So once we have a linear regression between competitor average price and seasonality index on the x-axis, and then suggested mid price on the y-axis. So all of this. So we have the model is linear regression. We fit the x and y data sets, data like that, and the coefficients. So we get the intercept and the coefficients for competitor average price first and seasonality index, and then we want to read off suggested mid price based on this. So this is a very scientific way of taking of getting pricing done. Okay. All right, so we're here now. So I just run this and see what it gives. So you see the intercept is minus 67.215. So it means that before you even start, like when there's no activity, you have something negative price already. But then for the coefficient and for computer average price, you have 1.0967. That's a positive value, right? So it's more like if you want to write the equation, you have um suggested mid price is equal to 1.1 multiplied by competitive average price plus 61 times seasonality index, right? So that's what the equation is going to look like in that case. Of course, minus 61, I minus 67.2, right? So all that. So depending on what value you now put in, that will give you. So this is a very good model for pricing your your what you're selling, right? So this equation can be really helpful to say, okay, based on all the data we have, this is the best price for this particular thing. So, and that's some very scientific and empirical way of determining your price for your products. So we can also compare predicted versus actual. So in this case now, we've done the linear regression up there. How well does this look? Okay, because yeah, of course you have indices to measure that, but when we get to data science and machine learning, we'll be talking about that. But right now, one of the easiest ways to see how well your model performs is to do a plot. Suggested mid price against actual, predicted mid price against predicted, and all that. So you want to see how all of that work together. And from the look of things, the actual is in blue, the predicted is in orange, and it's not bad at all, right? It's not bad at all because the lines almost match perfectly. Okay, so we see that the model performs reasonably well. Deviations suggest room for more sophisticated models. So if you have some little deviation, like maybe you have this kind of places where the yellow line, the orange line, and the blue line are not perfectly there, or somewhere like this. So it means you may need to use better models, as we are going to see later, like random forest or adding categorical features like product category. But I mean, we can reserve that for data science when we get there. Data science, machine learning, like that. So the key insights we see here is that seasonality plays a strong role in determining price because you have spikes in May and November, not March and July. You have spikes in May and November. Spikes in May and November. So it means you should get ready for those times for very serious sales. And that reflects increased demand. Then you have suggested prices are consistently higher than competitor prices, indicating a premium pricing strategy. So if you believe you are doing premium service, you have the liberty to do that. Maybe, I mean, just like a bottle of Coke can sell for, I don't know. Of course, in the Nigerian context, right? When a bottle of Coke was selling for like 50 naira, you get to a hotel and to a kind of hotel and it will be sold for 100. You get to another kind of hotel and it is sold for like 1,500. So it's all about where you're buying it from. So a linear model based on competitor price and seasonality index explains much of the price recommendation logic. So you can use that linear model to fix your price in a very scientific way instead of just just looking just taking it without any without data information from the data. So we also have that a few products uh like oh 08, oh 010 deviate significantly. This may require individual review or could be outliers. So if you look at this now, we have places like this. So the product index is around this is looking like 18. Did we say 8 here? So it's like 018. Then you have a bit of deviation around, say, oh, let's even look at the 8. Yeah, so you have some product, let me not worry about that. But you have some places where the products deviate significantly, and this may require individual review or could be outliers. So, but generally speaking, the model looks very well. The linear regression model looks very, very well. So, I mean, you can so this is to tell you that if you're doing anything, the data, so like some people say, in God we trust, every other person should present data. So you don't get into any business blindly. If possible, if you can get data to know. So whatever you're doing, it is informed. You are not just doing it haphazardly. It's really important. So this brings us to the end of this Capstone project on pricing recommendation tool. So all of this is telling us that whatever you're embarking on, be sure get the data. What does the data say? What anything you're doing, you should be able to explain it that oh, this is what we did based on this and that, like this. Okay. So I think I have about two capstone projects to go. Maybe I can make those two dashboards like that and see how things work. All right. So if you have an idea of what I should do, like if you need to learn about something, you can just let me know so I can tailor it towards your need if possible. Um, if you have subscribed, of course, you are learning a lot already. If you have not subscribed, be sure to do that right away and hit the notification bell so you can always get alerted each time a new video is released. And do not forget to like and share so that more people can have access to the great content we have going on here. Till I come your way again, keep doing data right. Bye.